Within a single afternoon, 10 mathematical problems that had resisted the world's best researchers for decades suddenly burst into pieces. These were solutions no human was expecting to see in our lifetime. The answers came from an unreleased OpenAI model called Astra. In a quiet research post, the company revealed that this system had cracked some of the most stubborn open questions in the history of mathematics. Perhaps the most shocking detail is the price tag. Generating these 10 world-class breakthroughs cost only about $2,000 in computing power. For perspective, some of these problems had been attacked by the world's most powerful supercomputers for 50 years without a single inch of progress. Astra succeeded by synthesizing entirely different fields of study, connecting biology to physics or geometry to logic, finding shortcuts that remained invisible to human specialists. This milestone marks a transition into a world where software independently discovers new scientific truths, rather than simply repeating what it learned from us. To understand how this works, imagine all human knowledge is a massive, ongoing puzzle book. Most AI models we use today act like an assistant. If you ask a question about a puzzle that's already been solved, the model flips to that page and points right to the answer we've already provided. More advanced systems act as reasoners. They can take a difficult, half-finished puzzle and work through a sequence of logical steps until they find the missing link that connects the dots on that page. But Astra functions as a researcher. It faces a completely blank space in the book, testing and discarding thousands of original ideas until it finds a valid proof and adds a brand new page of knowledge to the volume. Crossing the gap between reasoning through what we know and researching what we don't is the historic shift we are seeing right now. These new pages aren't just theoretical. They have real-world consequences for the technology in your pocket. One of Astra's breakthroughs involved sphere packing. It calculated the absolute limit for how many data points can be squeezed into a space by tiling them together as tightly as possible without them touching. This determines how much data we can cram into a single 5G signal. By following this new math, the static vanishes, allowing us to send massive amounts of information through the air without the signals scrambling each other. Astra also solved the Kahn's embedding conjecture. This asks whether we can use a small set of symbols to accurately map out an infinite system. For 50 years, mathematicians weren't sure if that shortcut was even possible until this model proved the answer. These solutions require the model to sustain a single complex line of logic for hours or days, demonstrating focus rarely seen in artificial intelligence. However, a mathematical proof has to be more than just convincing. It has to be perfect. Even advanced models are still prone to making small logical slips. To catch those slips, researchers use a system called Lean-4. It's a digital logic checker that compiles every step of a proof like computer code, rejecting the entire solution if even a single comma is out of place. Even with digital verification, human mathematicians still spend months auditing the AI's work to ensure the definitions are correct and the discoveries are truly original. OpenAI is also facing intense competition. Just days before Astra's announcement, a model from their rival, Anthropic, successfully disproved an 87-year-old math conjecture that had remained unsolved since the start of World War II. In this new environment, the ultimate test for any AI isn't how well it writes, but whether its discoveries can be mathematically verified by the world's experts. These leaps in capability have already reached the highest levels of government. OpenAI CEO Sam Altman recently held private meetings to demonstrate how teams of these AI agents can work together to solve difficult problems. He showcased this technology to policymakers at the U.S. Capitol to prepare them for new safety rules. These regulations will require advanced models to undergo strict security testing before they are ever released to the public. Renowned mathematician Terence Tao believes this is shifting the field of mathematics toward a factory-like model, where new discoveries roll off a digital assembly line. This leaves us with a profound question. How do we value human genius when the next great scientific breakthrough can be purchased for the price of a few computer tokens? We are watching the role of the AI change from a student that follows our lead to a peer that helps us map the unknown. The era of the AI research collaborator is here.